y. You don't have to write this part down. I'm just going to simply ask some basic questions. So if you think about like the y values for sine, okay? Remember that it starts at the origin, it goes up to 1, it goes back to the origin, it goes down to -1, and then it finishes at the origin, right? Okay? So think about the fact that if we're going to graph the cosecant curve, and the cosecant is reciprocals, what's the reciprocal for 0? Undefined. And if it's undefined, that means it becomes an asymptote. What's the reciprocal for 1? What's the reciprocal for 0 again? Undefined. So that's another asymptote. The reciprocal for -1 is -1. It doesn't matter the fact that it's negative. And then you have undefined again. All right. So what that means here is if I look over here at this graph, okay, that notice that when we have 0 for our sine, we now have an asymptote. At 1, it stays at 1, so both curves are going to be there. When it's at pi, you're back to 0, which now becomes an asymptote. You got your -1, and then you've got your 2 pi back at 0, which becomes another asymptote. Okay, so I just wanted to show you why the curve is the way it is. Okay, so just so you understand that. Okay, so what we're going to do is we're going to practice just graphing a basic cosecant curve. Okay, so you got y equal to cosecant of x. So this is the way that we're going to do it. We are going to, and you can leave the graph up there. Okay, you're going to graph a sine curve. What are the x values for our sine curve?
0, pi over 2, pi, 2 pi over 2, and 2 pi.
Okay, very good. So he says that we're going to start at the origin. We're going to go up to 1. We're going to be at pi. Pi is going to be back to the x-axis. Okay, we are going to be down to -1. Okay, and then we're going to finish at 2 pi. So this is our sine curve. All right, so based upon what we just said, over here on the right, we said 0, the reciprocal of it is undefined, so it becomes an asymptote. So now that means that our y-axis is now an asymptote. Pi now becomes an asymptote. 2 pi now becomes an asymptote. And then our curve basically is going to look like a parabola. We are going to graph here, and we are going to graph here. Okay, so it's going to look like, you know, a bunch of parabolas in between the asymptotes. So technically, the blue is your cosecant curve. Okay, so like, for example, if I were to erase, won't let me erase. If I were to get rid of the red curve, okay, what is left would be your cosecant curve. Okay? All right, so now the big question that is going to come up eventually is, well, what happens when there is a vertical shift? Okay? If there's ever a vertical shift, the point on the midline becomes your asymptote. The point on your midline becomes your asymptote. Okay? What I mean by that is if I were to go -1, which means that this now becomes our midline, okay? When our sine curve touches the midline, it now becomes an asymptote, okay? And so if it were to do this, it now becomes an asymptote, okay? So the points at where it crosses the midline is our asymptotes. Does that make sense? Okay, so just understand that. And the reason is, okay, think about just basic order of operations. You would do your cosecant curve first. That would create your undefined or your 0, right? And then you would subtract 1. And so if we have 0 here, okay, and then, or here, and then we subtract 1, okay, it's not affecting the undefined, okay? So just so you understand that idea, okay? Do we need to practice the basic secant curve? Yeah? Okay. So secant curve is pretty much the exact same thing. The only difference is, remember, that it is the reciprocal of cosine. So if we were to do our basic parent function for it, okay, remember that for cosine, we still have pi over 2, we still have pi, we still have 3 pi over 2, we still have 2 pi. Where do we start our cosine curve? At 1, and then we go down. At pi, we're all the way down at -1. At 3 pi over 2, we're back to the x-axis, okay, and then we finish up at 2 pi. So same concept. Anytime it crosses the x-axis, that becomes our asymptote because the reciprocal of 0 is undefined. So when you have a situation like this, you do not need to finish the graph. You can if you want. Okay, like if you wanted to finish this and then put an asymptote, you can, but you don't have to. You can basically graph it like this. So graph half a parabola, graph a full parabola between the asymptotes, and then graph half a parabola. Okay? Because we're only expecting you to graph one period length from 0 to 2 pi. All right? Sound difficult? No, like I said, you guys did a great job graphing your sine and cosine curves. So it's, as long as you're able to do that, which you've already shown that you're capable of doing, you should be fine. Yes?
Do you always want us to like make the
Sine and the
dots,
cos.
basically? Like, do you always want us to do that, or can we just like not connect, like the red ones? Can we not?
You don't have to graph the red line.
Okay.
You don't have to. For some people, it's easier for them, okay? But you do not have to, okay? In fact, what we could do is we could try and practice one where we don't.
Do we have to have like all the like the 2 pi and the pi in the middle, like because if those points aren't really important, or are they?
What do you mean? Do we have to just
Like, do we even
label
need
it, or?
Yeah, like the x-axis. Do we really need to label it that much then, or could?
Well, remember that once we get into changes in period length,
Yeah.
those values are going to change.
But if they don't change, do you still?
Well, I would like you to still label them just to show that, okay, it didn't change and that those are our x values. Yeah.
Do you have to make the sine and cosine then?
Yeah, so that's what Zoe was asking. You do not have to. It's up to you, okay? So I put on one of the homework, I did it without, and only because the question before was the same exact question. It was the sine, and then right underneath it was the cosecant. Well, I wasn't going to draw a sine all over again. I could use the above graph to figure it out, okay? All right, so let's go to the backside where we can practice an example, okay? So I'll show it the one way, and then what we can do is we can come back and do it another way, okay? So the one way I'm going to show it is with the idea that we are going to graph 2 cosine of 4x plus 1, okay? So when we were graphing our sine and cosine, the very first thing we said to do was to focus on the fact that you have a vertical shift, which means that we now have a midline at 1. Okay, so now that's done. Then we said to focus on the fact that you have an amplitude of 2. So what does that tell us? That we go up 2 to the top of our graph and then down 2 to -1 for the bottom of the graph. So that's done, right? Go ahead.
Wait, should we have the 3?
Sorry. I said up 2 and wrote 2, and it should be a 3. Yes, thank you. Okay, all right, so then we have the 4. So this goes to your question. What is the 4 going to do to our x values?
Shrink them.
It's going to shrink them, okay? So if I take 2 pi and divide by 4, that means one period length becomes pi over 2, right? So if you need to do the chart still, you can do the chart, but otherwise, does anybody know a way to split pi over 2 into 4 parts, 4 equal parts. Pi over 8. So there you go. So we've got pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and then we finish at pi over 2. And there was no, phase shift on this one. If you need to, go through the chart and do your 1 over b, and you can get those same values, okay? All right, so since it's a cosine curve, we're going to start at the 3. We're going to come down to the midline at pi over 8. We'll go down to -1 at pi over 4, back to the midline, and then finish up at the top. All right, so if I were to graph the entire curve, I get this. And then based upon what I said a second ago, when you go to graph your secant curve, remember anytime it crosses that midline, that becomes your asymptote. And so now my curve starts at the y-axis and goes up to the right. Between the two asymptotes that I graphed, I have a little parabola, and then I have a half parabola between 3 pi over 8 and pi over 2. Okay? Did we need to graph the red line? No. Okay, but that's up to you.
Well, isn't it always going to be the first, like the pi over 8 and the 3 pi over 8, the first and the third?
For
Yeah.
cosine, for
asymptote?
cosine, yes.
Yeah.
For sine, it'll always be the very first one, the third one, and the fifth one. Yes. So for cosine, it's always, I would consider this 2 and 4, because the y-axis would be 1, right? So 1, 2, 3, 4, 5, so 2 and 4, but sine, it'll be 1, 3, 5 for asymptotes. That's a good way of looking at it. Good job. Okay? All right. Let's go to number 2 then. This one is going to involve a phase shift. So first thing, even with these secants and cosecants, always write it in factored form. So cosecant of what? 2, parentheses, x pi over 8. Okay? All right. Do we need to do the chart? No? You feel confident doing it without? Okay. Reminder that if you need to, you could start by thinking about graphing sine of 2 parentheses x plus pi over 8. Okay. So think about simple ideas. Our period length, 2 pi, divided by 2 becomes a length of pi. How can we split 1 pi into 4 parts? A quarter, a half, 3/4, and then finish at pi. But remember that everything got shifted in which direction? Left. Okay? So if you're doing it without the chart, understand that we're now starting at negative pi over 8. And now our next point is going to be 1/4 later. So what's pi over 8 plus a quarter? Pi over 8. Okay. What is pi over 8 plus another quarter? What is it? 3 pi over 8. Okay. What's 3 pi over 8 plus another quarter? 5 pi over 8. I think I see a pattern here. Okay, and then one more. 7 pi over 8. Okay, and notice from negative pi over 8 to positive 7 pi over 8 is a length of 1 pi. Okay, remember you can get those values by creating the chart with the 1 over b and the c. We just tried to show it without. Okay, amplitude is still going to be at 1 and -1. Okay, all right. So reminder that since we're talking about a sine curve, we would start at the negative pi over 8. We would come up to pi over 8. We'd go back to 3 pi over 8, all the way down to -1 at 5 pi over 8, and then go here. Your asymptotes are going to be wherever it crosses the x-axis. And so now, instead of graphing the sine curve, okay, like a couple of you asked, can we just do it without? You can just graph this and graph this, and you're done. If you wanted to graph the sine curve, you can. It's not going to be wrong. All right, so just big idea with this, the trickiest part of the whole thing, and you saw it on the last example, okay, is just remember that wherever it crosses the x-axis or wherever it crosses the midline, that is where your asymptotes are going to be, okay? Everything else is just, you have to be able to come up with your, new x values and y values, okay? Any questions?